Have we really been to the moon? This question has puzzled many for decades. The moon landing, an event that supposedly took place in the summer of 1969, has been the subject of skepticism and conspiracy theories for years. The first man on the moon, Neil Armstrong, his steps broadcasted around the world, the iconic footprint, it's a story we all know. But how much of it is true? Consider the lack of direct witnesses. The only people who can claim to have seen the event firsthand are the astronauts themselves. The rest of us, billions across the globe, had to rely on grainy television broadcasts and the word of NASA. We were all spectators, not participants. Then there's the matter of the stars, or rather, the lack thereof. In all the photographs taken by the astronauts on the moon, not a single star can be seen. NASA claims this is due to the brightness of the lunar surface washing out the faint light of the stars. But could there be another explanation? And let's not forget the waving flag. In a vacuum like the moon's atmosphere where there is no wind, how could the American flag appear to ripple as if caught in a breeze? NASA's explanation is that the flag was stored in a thin tube, and the rippling effect was caused by it being unfurled before being planted. But many remain unconvinced. These anomalies and inconsistencies have led some to question the authenticity of the moon landing. Could it have been an elaborate hoax? A Cold War-era deception designed to declare victory in the space race? Or are the explanations provided by NASA sufficient to dispel these doubts? These anomalies raise questions about the authenticity of the moon landing. As we delve deeper into this mystery, remember the truth is often stranger than fiction. And in this case, the truth may be hiding in the shadows of the moon itself. Moon rocks brought back by astronauts have also been the subject of controversy. They're intriguing, mysterious, and to some, they're the smoking gun that points to a grand deception. But let's not jump to conclusions just yet. Let's take a closer look. The moon rocks collected during the Apollo missions have long been under scrutiny. Some skeptics suggest that these rocks were not lunar at all, but rather terrestrial in origin, or even meteorites. They argue that it would be much easier to pass off a rare Earth rock or a meteorite as a lunar sample than to actually go to the moon and bring one back. One of the main points of contention is the age of the moon rocks. By all accounts, these rocks are ancient, even by geological standards. Their ages range from 3 to 4.5 billion years old. That's significantly older than the majority of rocks found on Earth. But isn't it strange? The moon and the Earth are said to have formed around the same time, so why is there such a discrepancy in the ages of their rocks? And then there's the infamous Dutch moon rock. In 2009, it was revealed that a moon rock given to the Dutch Prime Minister by Apollo 11 astronauts in 1969 was actually petrified wood. How did that happen? Was it a simple mistake, or was there something more to the story? These discrepancies and oddities have led some to question the authenticity of the moon rocks and, by extension, the moon landing itself. It's a fascinating rabbit hole to explore, filled with scientific intrigue and a dash of conspiracy. The inconsistencies in the moon rocks further fuel skepticism about the moon landing. But as with any theory, it's important to keep an open mind and critically examine the evidence. After all, isn't that what makes the pursuit of truth so exciting? The Van Allen radiation belt poses another challenge to the moon landing theory. Picture this: two donut-shaped zones of high-energy particles, mainly protons and electrons, encircling our planet. These are the Van Allen radiation belts, named after James Van Allen, the scientist who discovered them in the late 1950s. These belts are held in place by Earth's magnetic field, and they pose a lethal threat to humans due to the high levels of radiation. Now, let's turn our attention back to the Apollo missions. According to NASA, the Apollo spacecraft passed through the Van Allen belts on their way to the moon. But here's the kicker: the technology to shield astronauts from this intense radiation simply didn't exist in the 1960s. Yes, the spacecraft had some minimal shielding, but it was not nearly sufficient to protect against the levels of radiation in the Van Allen belts. Some argue that the trip through the belts was so quick that the astronauts weren't exposed to the radiation long enough to be harmed. But consider this: even brief exposure to high levels of radiation can cause acute radiation syndrome, leading to a host of health problems. and potentially death. Others suggest that the Apollo spacecraft were steered through thinner parts of the belts to reduce radiation exposure. However, even the thinnest parts of these belts contain dangerous levels of radiation. And remember, the technology to accurately measure and map these belts was not available in the 1960s. NASA has admitted that they're still figuring out how to protect astronauts from the Van Allen radiation for future Mars missions. This begs the question, if the Apollo astronauts really did pass through the Van Allen belts, how did they survive unharmed? It's a question that continues to fuel skepticism and fuel the debate over the authenticity of the moon landing. The mystery of how astronauts survived the Van Allen radiation belt remains unsolved. Scene script. Have you ever questioned the authenticity of pictures of Earth? It's an intriguing thought, isn't it? Now let's delve a bit deeper into this question. The first thing you might say is, but what about the famous blue marble photograph? That's a great point. The blue marble is one of the most recognized photographs of our planet, taken by the crew of Apollo 17 in 1972. But here's an interesting fact. It's not one single photograph. It's a composite of multiple images. This fusion is done so seamlessly that it's hard to notice at first glance. However, upon closer inspection, you might start to see the stitches that hold this grand tapestry together. And it's not just about the blue marble. When you start comparing different images of Earth, some discrepancies begin to emerge. For instance, let's take a look at the size and color of continents. In some images, North America appears larger than Africa, while in reality, Africa is about 3 times the size of North America. And the colors, they range from intense blues and greens to washed out, almost monochromatic versions. Shouldn't there be more consistency? Also, consider the fact that we've supposedly been in space for over half a century. With all the advancements in technology, why don't we have a plethora of real unedited photographs of the entire Earth? It seems a bit odd, doesn't it? Now, we're not saying that all these images are intentionally deceptive. They could be the result of various factors like different camera lenses, angles, lighting conditions, or image processing techniques. But the point is, these inconsistencies do exist. And they add another layer to the mounting questions about the veracity of our space exploration endeavors. The inconsistencies in images of Earth add to the growing doubts about space exploration. The moon landing and pictures of Earth have been subjects of debate for years. As we've unraveled in our discourse, there are several threads of evidence that challenge what we've been told. First, we examined the peculiarities surrounding the moon landing. The American flag's fluttering motion in a supposedly airless environment, the absence of stars in the lunar sky, and the unscathed film reels despite extreme lunar temperatures, all raise questions about the authenticity of the moon landing. Next, we delved into the inconsistencies found in moon rocks. Some believe these rocks, supposedly brought back from the moon, are indistinguishable from Earth rocks or even meteorites. Others point out oddities in their age and composition. These doubts cast a shadow over the narrative of lunar exploration. Then we ventured into the Van Allen radiation belt mystery. This deadly zone of radiation surrounding the Earth is said to be lethal for humans and electronics alike. Yet the Apollo mission supposedly passed through this belt without any significant harm to the astronauts or their equipment. This discrepancy calls into question the feasibility of these missions. Finally, we discussed the lack of real pictures of Earth. Most images we see are composites, computer-generated, or artists' renditions. The scarcity of genuine, unaltered photos of our planet from space fuels skepticism about the extent of our space exploration. In conclusion, these pieces of evidence, the anomalies in the moon landing, the inconsistencies in moon rocks, the mystery of the Van Allen radiation belt, and the lack of real pictures of Earth, all compel us to question the narrative we've been presented about space exploration and moon landing. The evidence suggests that we should question what we have been told about the moon landing and space exploration. What do you think? Have we really been to the moon?